radians and trig functions. It's not going to be a whole lot today. So we've already talked a lot about what coterminal angles are, correct? They're the ones that, like, you just keep going around the circle and it's going to land in the same place as something else. So we've got a few that we're going to do up here for that. So the first one is 17 pi over 4. So we could, like, look at your unit circle and count your pi's over 4s till we get to, like, 17. You could do that. But like I said earlier, I get really confused with the radians, so I like to convert it to degrees. Do y'all want to do that, or do you want to do it in radians? I like degrees, so let's convert 17 pi over 4 to degrees. And then see what we get for that. What do we get? What do we get for that in degrees? In degrees, what is 17 pi? 765. It's 765 degrees. So I'm going to say this is 765 degrees. And then we said we're going to subtract 360 till we get to something 360 or smaller, right? So it'll be on our unit circle. So we'll do that a couple times. And what do we get? 45. So this is really just asking you what is sine of 45. And what is sine of 45? Yeah. If you want to do that, that's fine. I just like degrees better. That's just me. But if you can see that and you're good with that, then do that. I like degrees, so I'm going to convert it to degrees. But you keep doing what you're doing. Is that okay? So again, sine of 45 or sine of pi over 4. What do we get there? The exact answer. Square root 2 over 2. So if you need to have, like, your unit circle out, then I would have that out. I mean, I've got mine to look at just in case. We already forgot everything? Awesome. Okay. So glad we had a quiz. All right, looking at number 2, we need to find cosine of 5 pi. So I think this one is kind of easy to leave it in radians because it's like a whole number, right? So we know that we're trying to do 5 pi. So we've got 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Yeah? Does that make sense? So we're looking at right here, and what do we want? Cosine. So what is cosine right there? -1. Yeah? That okay? All right. And then the last one is 5 pi over 4. So that falls on the unit circle already, correct? Yep. And what is tangent at 5 pi over 4? So if we're looking at 5 pi over 4, tangent. Negative over negative is going to give us positive. So it would be +1. Is that okay? Yeah, any questions so far? Wonderful. All right, so if we're talking about the signs of the trig functions, you can look at our like our Cartesian plane or whatever. So we know that quadrant 1 is plus plus, quadrant 2 is minus plus, quadrant 3 is minus minus, and then quadrant 4 is plus minus. So we have like a little mnemonic device to help you remember what's positive where. And so that's all students take calculus. So everything, all things are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And then cosine is going to be positive in quadrant 4. So that's just to help you remember that. Yeah, that's all that this is saying. So then if we're looking down here, it says if sine is negative and cosine is negative, what quadrant does theta have to fall in?
Tangent.
What quadrant is that?
Well, 3.
3. Does that make sense? Where sine and cosine are both negative. So it would have to be in quadrant 3. So the next part, it says find the sign of the expression if the terminal point is determined by t in the given quadrant. So we're going to do cosine times sine, and it's in quadrant 2. So if we're in quadrant 2, they're opposite signs. So when we multiply them, what's it going to be? It's just going to be negative. And that's all it wanted us to give them there. Does that make any sense? Yes, so maybe. Questions on that? All right, cool. So yesterday we were talking about all of your trig functions in terms of x and y. So today we're starting to talk about them in terms of each other. So you've got a bunch of reciprocal identities here. So like we were saying yesterday with cosecant, that it's just the reciprocal of sine. So like we were doing 1 over y, it's just 1 over sine, that's all that's the same, so it's not really anything different. This might be new right here. Tangent is sine over cosine, and then so cotangent is going to be cosine over sine, so you just flip that. Pythagorean identities are at the bottom. Have we seen these before? Yes, no, maybe. That's what those are. So you've got like sine squared plus cosine squared is 1, and tangent squared plus 1 is secant squared, and then 1 plus cotangent squared is cosecant squared. We can manipulate those, so like solve for whatever you need there. So when we start working with identities more and just like simplifying trig expressions, you'll use those. Yeah, so that's that. All right, looking at the bottom, it says you're given sine and you're given cosine to find the exact values of the 4 remaining trig functions of theta using your identities.
Weeble High School, this is Principal Johnson. Please pardon this interruption for a brief announcement. We will be participating in a statewide drill later this morning for Severe Weather Awareness Week. At 9:15, I will give you more instructions for this drill. Remember that we will not move to our assigned areas during a tornado watch. We will only move to our assigned areas during a tornado warning.
That's great.
Again, at 9:15, I will go back on the intercom with further instructions.
Sometimes this is happening in the middle of my video. So when we have a tornado warning or whatever, the one where you have to move, we're going to go downstairs and then towards like the like shop classes in the middle hall. Yes, I'm positive. Do we all understand where we're supposed to go? In the event of an emergency. Yeah, well, don't follow anybody else. You're going down the stairs in the middle. We're going down the stairwell on this side, so don't go down the stairwell on that side. We're specific about this, okay? And then we're going to the middle hallway, like past the office and guidance. Yes, right in there. And then when we get down there, you have to assume the position to show me that you know what you're supposed to do. And then you can just sit normal, okay? Yes. All right, cool. So let's do some math. So we're given sine and cosine. We have to find all the rest of the identities. So we can go ahead and do tangent. So up here it says that tangent is sine over cosine, which we know that from yesterday. We were doing y over x. So that's what we're going to do here. So sine is square root 5 over 5. And we're going to do that over cosine. So I'm going to go ahead and multiply by the reciprocal of cosine because that's what we would do when we divide anyway, right? Do I need to write that out? I won't skip that step. We'll write that out. Okay, leaning in. Hey. Sure. Can you guys see Mr. Spencer? All right, so this is going to be square root 5 over 5 times 5 over 2 square root 5. The 5's cancel, the square root 5's cancel. What are we going to be left with? 1/2. Is that okay? Questions there? All right, so we know that tangent is 1/2. So it's going to be super easy to find cotangent from there, right? Because we'll just flip that. So what is cotangent going to be? 2, because you're flipping 1/2, so it's just 2. We still need to find cosecant and secant. So we know that cosecant is 1 over sine. So we can just flip sine, right? So we'll have 5 over square root 5. And when we rationalize that, how are we going to do that? Because we don't want square roots in the denominator. Good. Multiply by square root 5 over square root 5. So that's going to be 5 square root 5 over 5. The 5's cancel, and we just have square root 5. Then to find secant, we're going to do the reciprocal of cosine. So we'll just flip cosine, so we'll have 5 over 2 square root 5. So again, to rationalize that, what are we going to do? Multiply by square root 5 over square root 5. So it's going to be 5 square root 5 over 2 times 5. And those 5's cancel, so we just have square root 5 over 2. Questions on any of that? Okay, there, we'll move on to the back. All right, so if we are looking at the next ones, so we're going to use identities here. So we've got tangent of 20 minus sine of 20 over cosine of 20. So how could we rewrite tangent in terms of sine and cosine? Do you remember? Flip back over the back. What does it tell us that tangent is? Sine over cosine. So this we could say is just sine of 20 over cosine of 20 minus sine of 20 over cosine of 20. And what's that going to end up being? 0. Is that okay? So you could go the other way there. So if you recognize that sine over cosine is tangent, you could have rewritten that as tangent 20 minus tangent of 20. It's still the same thing. Generally, we want to try to get everything in sine and cosine, so that's why I went ahead and went there instead of going to tangent. Looking at the next one there, we've got sine squared of pi over 12 plus 1 over secant squared of pi over 12. So, what can we do with this? Any idea? So let's look back on the front and see if we can find anything that might be helpful. So secant is 1 over cosine, right? So if we've got secant squared, that would be like 1 over cosine squared there. So we could rewrite this as 1 over cosine squared pi over 12. Is that okay? And so that, when we have the, like when you multiply it out, that's going to be like 1 over 1 times cosine squared over 1. So really, all of this is just cosine squared, right? So we can say that's sine squared of pi over 12 plus cosine squared of pi over 12. And then again, back on the front, that's sine squared plus cosine squared. If you look, it's a Pythagorean identity. So as long as your angle measures are the same and they're both squared, add them together, what are you going to get? 1. So this whole thing is just 1. Is that okay? Questions on that? So we're just applying those identities that we talked about on the front to simplify these a little bit. That's all that's going on there. Questions? Alrighty, so looking at the next one, it says given that sine equals 1 over 3 and cosine is less than 0, so it's negative, find the exact value of each of the remaining 5 trig functions. Yep. So we have sine, and we know that cosine is going to be negative. That's it. So we know that sine is 1 over 3, so what would be easy to find from there? Cosecant, because that's the one that goes with sine, right? So what would cosecant be? Because we're just flipping that sine. Don't type that wrong. I think that's typed wrong. Can we change that 1 over 3 to 1 over 2? Because there's not a 1/3 of sine on the unit circle. Yeah, let's change that to 1/2 instead of 1/3. Is that okay with you? I'm sorry, I goofed. So then cosecant instead of 3 is going to be what? 2. All right, so if sine is 1/2 and cosine is less than 0, so cosine is negative. What quadrant is sine positive and cosine negative? Where does that happen?
2. 2.
So where cosine is negative and sine is positive? I mean quadrant 2, right? So we're going to look in quadrant 2. So where is sine 1/2 in quadrant 2?
150.
At 150 or 5 pi over 6? Does that make sense? So then cosine there is what? Negative root 3 over 2. So we can put that in there. Cosine equals negative root 3 over 2. Put a theta in there as well. Now that we have cosine, it's super easy to find what? Well, yes, the rest of it, but what goes with cosine? What goes with cosine? Secant, so we'll just flip cosine and we'll have secant. So secant is going to be negative 2 over square root 3. And we need to rationalize that, so what are we going to do?
Multiply.
So that's going to be negative 2 root 3 over 3. So what do we still need to find? Tangent and cotangent. So let's do tangent first. What is tangent again?
Y over x.
It's y over x, or in terms of sine and cosine, which one's on top, which one's on bottom? Sine over cosine, right? So we're going to have 1/2 over negative root 3 over 2. So then when we go simplify that, we're going to have 1/2 times negative 2 root 3. The 2's cancel. We're going to have negative 1 over root 3. Can we leave it like that? No, so we're going to have to rationalize. So times root 3. And this is going to be negative root 3 over 3. Is that okay? Questions on that? Okay, great. So then the last thing that we have to find is cotangent. How are we going to do that? Just flip tangent. So we could flip it from here, but if we like back up just a little bit, I think it's easier to flip from right here because we won't have to like rationalize again. So if we flip negative 1 over root 3, that's just going to be negative root 3, right? So negative root 3 is your cotangent there. Because these were negative. So then when you flip it, it's still going to be negative. Yeah, so we got to figure out where tangent is going to be 1/2 on number 5. Does anybody have yesterday's notes handy? Because y'all remember that, was it yesterday's? There's a chart on it that gives you like all the signs for a bunch of stuff. Do you know what I'm talking about? If you want to look on that, it might tell you where tangent is 1/2. And if not, then we're just going to have to find it by hand.
What you say? I got the notes right here. Oh.
Is tangent 1/2 anywhere? No? It's not? Are we sure?
Oh yeah, we're about to be moving.
About to be moving. Okay, so let's do this. Let's skip this one. We're going to talk about the bottom section real quick. That way we're done by the time we have to move for the drill. I know. Okay, so we're talking about even and odd properties of your trig functions. So this is what they are. So we've been confused about like how to find if something's even and odd. We did that a long time ago, and I think we've just forgotten. So if you're checking to see if something's even, that's where you plug in the negative x, right? And then evaluate, see that it comes back to your original function. That's what this is telling you right here. And if it does, then it's even. If it doesn't, then we then plug in the negative y. And if then it comes back to your original function, we call it odd. So that's what this is talking about there. So we can still apply that to your trig functions. So there is all of that. So basically, if the angle is negative, then you can just make the whole thing negative. That's what this is saying. So for the first one, we've got sine of negative 45. So that's going to be the same thing as like negative sine of regular 45 or positive 45. And what is sine of 45? Square root 2 over 2. So this would be like negative square root 2 over 2. And like before today, when we had something like that, we would just go backwards around the unit circle, correct? So you would just go like down 45 degrees instead of up, and you still end up with negative square root 2 over 2 there. Is that okay? So either way is going to get you to the same place. Do we have questions on that? All right, so for the next one, we're talking about cosine of negative pi.
We are now under a tornado watch.